The topic timber is here divided into two parts. The first part we will be looking at is the desirable properties types of timber, and in the second part we will take a look at some objective questions regarding preservation of timber and defects found in timber. Okay, so let's go with the first part, in which we are going to see types, then characteristics and desirable properties. So the first question in front of us is saying that timber which is obtained after felling a tree is called as. Okay, and the options we are provided with are converted, rough, standing and none of the above. Okay, let's look at what converted, rough and standing timber is. See, converted timber is the one which is a processed wood. Okay, processed wood means the wood may be converted into, or the timber may be converted into logs, okay, or struts or elongated members. Okay, it is called as converted member, means timber sent to the sawmill and then it is processed, converted into a proper shape which can be directly put to engineering purpose, is called as converted timber. Then the rough timber is there. Rough timber means the moment you cut down a tree and it falls upon the ground, then the timber, the wood that you obtained is rough timber. Okay, and standing timber is nothing but trees which are planted, which have full grown, which are then to be used as timber, is called as standing timber. Therefore we are concerned with timber obtained after felling a tree is called as what? Rough timber. Okay, after you have fallen a tree, after you have cut down a tree, then the timber that you are going to obtain is the rough timber here. Okay, then question number 2 is saying timber is used as building material for following properties such as. Okay, see, several properties are mentioned here, 5 properties are given here, and out of that we have to check, we have to tick the properties which are suitable for engineering purpose or engineering projects. See, the first point is saying uniformity is strength. But is it true that uniformity in strength is available in all timber? No. See, timber with respect to its type, with respect to the tree type, okay, with respect to specific sample, the strength uniformity is not available. That's why point number 1 is not the justifiable one for which we are using timber. Okay, then uniformity in dimension, no. After we are cutting down the timber, when we are processing it, only when the timber is converted, then it has the uniformity in dimension. Timber which is available, then it is not having, it does not have the uniform dimensions. Okay, therefore point number 2 is incorrect. Okay, then low heat conductivity, yes, this one is true regarding timber. Timber is a kind of insulator. In building material, in building construction application, we are using timber or wooden flooring which has low heat conductivity, or we can say it is a kind of insulator. It does not lose heat or gain heat. Okay, means where winter seasons are dominant, where temperature fall is dominant, the timber or wooden floor is used. Then it possesses good resistance to building. Yes, it does have the resistance to bending. Then bulk density of timber is low, which is a desirable engineering property. That's why we will go with point number 3, 4 and 5. That's why the correct option here should be the one consisting 3, 4 and 5 number points. Okay, the wrong points here are uniformity in strength and uniformity in dimension. See, we have to process the timber accordingly for getting the dimension, and for strength is not never uniform in any given two kind of timber samples. Okay, let's go to question number next, which is fill in the blank. Trees grow in bulk in outward direction. See, endogenous trees are the one that grow in inward direction. Okay, grow in inward direction. Okay, then we are having this exogenous trees are the one that grow in bulk in outward direction. Okay, exogenous trees are the one that grow in bulk in outward direction. There is no term such as extrogenous. Okay, it is mentioned here just to make the confusion in between exo and extro. Okay, extrogenous is not a term. Okay, therefore the answer we are looking for is the exogenous trees. Exogenous trees grow in bulk in outward direction. They are more useful in engineering applications. Okay, let's go to question number next. Then we are having this, that conifers and deciduous are the subtypes of. Okay, see, conifers is the softwood. conifers means soft wood and deciduous means hardwood. Okay, remember this, conifer is softwood, deciduous is hardwood. Okay, and we are literally looking for the timber here, which is much useful in engineering projects, engineering construction or engineering or construction application. We are looking at coniferous and deciduous tree, which are subtypes of exogenous trees. Okay, remember it, exogenous, the trees that have their bulk growth in outward direction are called as exogenous trees, and conifers and deciduous trees or deciduous types are the subtypes of exogenous trees. Conifer, softwood, then deciduous, hardwood. Okay, remember it. Now let's go to question number next, which is saying, for engineering application, mostly fill in the blank trees are put to use. Okay, for engineering application, which kind of trees we are going to use? See, endogenous are not useful because their growth is having the bulk growth in the inward direction. Therefore, larger log, larger cross section is not available with which kind of trees? Endogenous trees. Then conifers, we just saw conifer is softwood. Okay, now in all practical engineering application, we need a better strength, good durability of the wood. That's why we will not go with softwood, which is liable to get deteriorated with respect to time. It is prone to breakage, it is susceptible to damage. That's why we will not go with conifer. The correct option here is deciduous, because deciduous is hardwood. Okay, deciduous is hardwood, and we require a wood which has good strength properties, durability properties. That's why we always go with deciduous wood. It is heavy, it has more specific gravity. Okay, therefore its weight is more, its strength is more. That's why for engineering application, mostly we are going with deciduous trees. Okay, let's go to question number next. Okay, we have to make selection of the properties associated with deciduous type trees or associated with hardwood type trees. Okay, therefore the first point which is saying is fast growth. No, in deciduous type trees growth is slow, growth is very less with respect to passage of time. Okay, on the other hand, the conifer, the softwood have better growth, faster growth. Therefore, the first point regarding hardwood, that they grow fast, is wrong. Then they are available in darker color. Yes, conifer, softwood are available in which lighter colors. Okay, they are kind of faded color. But when you are talking about hardwood, if you have to identify hardwood and softwood, you have the visual parameter of its color, which is dark color is associated with hardwood. Yes, therefore point number 2 is right. Then high weight density. Okay, if you have been provided, if you are provided with a log of wood, two logs of wood, then the lighter one will always be conifer or softwood, and the property of hardwood is its weight. Okay, its weight density is more, therefore its weight is more. Therefore point number 3 is right. Then good strength along and across the grain. Okay, see, when you are talking about along and across the grain, we are talking about along which direction of wood. Let's say this is a log of wood. Okay, and remember, the grain alignment of a wood or timber or log of timber is along its length. Okay, see, this is the length L of this log. Then its fibrous arrangement, grain arrangement, is always along its longitude. Okay, always along the longer dimension, and longer dimension of timber is nothing but its length. Or in when we are saying that the tree is in standing position, its height is its dominant dimension. Okay, then good strength along and across grain. Along the grain means in this direction it has good tensile compressive strength, and in across the grain means in this lateral direction perpendicular to the grain orientation direction, its strength is good. Okay, in case of conifer, if we observe the conifer, then softwood's strength is along the grain only. Okay, in case of softwood, the good strength parameter is available in this direction only. But when we are talking about hardwood, the strength is available in along and across directions. Easy conversion. See, if the timber is hard or if the material is hard, it is having good specific gravity, good durability, then its conversion or processing or workability, let's say the summarized term here is we are talking about is workability of a hardwood is kind of difficult. Okay, its conversion, its processing is difficult. Powerful tools, okay, then automatic machinery is to be put to use when we are treating, when we are dealing with hardwood. Therefore easy conversion is not a property associated with hardwood. Therefore point number 5 is wrong. Therefore we will go with point number 2, 3 and 4 here. Let's see the option. Okay, option C is saying point number 2, 3, 4. Okay, hardwood has dark color, it has more weight density, therefore it is heavy, and it has strength along grain's longitudinal direction as well as lateral direction of grain arrangement. Okay, so let's go to question number next. Alright, the question is state whether the following statement is true or false. And the statement is saying hardwood's age prediction is easier than softwood. Okay, let's first see how the age prediction or age calculation or age determination is done in case of wood. Let's say you are having this log of timber or log of wood. What you will do, you will take a saw like this, okay, and what you will do, you will cut along its cross section. Okay, along this cross section you are going to cut the tree. Now when you will observe the cross section, you will find out that there is a core that is center, then some rings are there. Okay, some rings are there, and these rings are called as what? Annual rings. Okay, what we are calling it as annual ring, and number of this annual ring is exactly the age of tree in years. Okay, now let's see what is the matter regarding hardwood and softwood's age prediction. See, hardwood's growth is fast. Okay, they grow in bulk in very fast manner, that's why their annual rings are easily distinguishable. Okay, their separation in between each layer, each annual ring layer is kind of distinguishable or easily visible. And when we are talking about deciduous trees, okay, when we are talking about deciduous trees, that is hardwood, their growth is kind of slow, and the annual ring, if we look into a cross section of deciduous tree, the annual rings are very much closely spaced. That's why what will happen, the distinction in between the annual ring in case of hardwood or deciduous tree is not that easy, is not that faster. Okay, you cannot just directly see and count the number of annual rings over there and tell the age of the tree in years. Okay, that's why in case of softwood it is easy for mentioning or for determining the age of the tree, but when we are talking about hardwood it is not easier. That's why the statement that is provided here, that hardwood's age prediction is easier than softwoods, is false. Okay, remember it. Conifers age prediction is easy, softwood's age prediction is easy because the annual rings present in softwood or conifer are easily distinguishable, and in case of hardwood the growth is slow, the layers, annual rings are indistinguishable. That's why their age prediction or age determination is difficult. Okay, so with this let's go to question number next. Okay, we are having a diagram also for better explanation here. We are looking at the central or innermost or core section of timber is called as what? Is it inner bark? Is it sapwood? Is it hardwood? Or is it pith? See, let's go into the diagram. This is the cross section of a timber. Okay, this is what? Cross section of a typical timber section. See, the innermost here. Okay, I am darkening this point. Okay, the innermost darkened brown point is called as what? It is called as pith. P-I-T-H, pith, or it is also known as medulla, M-E-D-U-L-L-A. Okay, the central or innermost core or core section of a timber is called as pith or medulla. Pith or medulla. Okay, let's see the option number D is saying pith. Okay, pith is the core center, or it is the centermost item which is present in the cross section of a timber log. Okay, so let's go to question number next. Inner annual rings along the pith are called as okay, we just saw what is pith. Inner annual ring along the pith are called as, see, Let's see where pith is. Okay, we know where pith is. This one is pith. Okay, the dark brown dot here is pith. Now the inner annual ring. Okay, ring number 1, ring number 2, ring number 3. What these rings are called as? See, these rings are called as, these 3 dots, these 3 rings are called as heartwood. Remember it, heartwood. It is the hardest section that is available in a timber. Okay, it is very durable, it is very rigid, it provides strength to the timber. Okay, the strength parameter which is provided to the timber is by virtue of heartwood. Okay, heartwood. Therefore the correct option here will be option D, heartwood. Okay, let's go to question number next with this. All right, they are asking about sap, and let's see what the options are saying. Sap, is it the softest part of a tree? No. Is it the water content of tree? Sort of. Okay, and point number C is saying fluid that carries nutrients, minerals, hormones of the tree with water. Yes, this is the most logical and correct option regarding definition of sap. Okay, since option A is wrong, we are going to directly cut all of the above. Now let's see how we are differentiating the point that it is water content and fluid that carries nutrient, minerals, hormones with water. If you want to directly mention what sap of a tree is, you can literally say sap of a tree is tree's blood. Okay, blood of the tree is its sap, blood of tree. Okay, and when we are talking about blood of the tree comparison, when we are doing, then you should get that the blood carries all the essential components which are required for maintenance and growth of the body. That's why when we are talking about sap, sap is the fluid that carries nutrients, minerals, hormones required for the growth and maintenance of the tree along with water. That's why it's not just water, but it is more than water. That's why the option selection between point B and C should be option C. The most correct option is option C. Also, whenever we are dealing with multiple choice question, then there is, most of the time you will be saying there are no wrong answer but most correct answer over there. You have to make the choice regarding the most correct available option alternative which are provided in the 4, 3, 2, whatever number of options which are given over there. That's why sap of the tree is fluid that carries nutrient, mineral, hormones along with water. Okay, let's go to question number next. Okay, fill in the blank indicates recent growth of the tree. Okay, fill in the blank indicates recent growth of the tree. Now let's go to the diagram. Okay, this one's what? Pith of the tree. This one's what? Heart. Okay, now these layers, okay, these 1, 2, 3, 4 layer, these layers indicate the recent growth of the tree, and these layers are known as sap wood. Okay, now if we make comparison in between sapwood and hardwood, comparatively sapwood is lighter in weight, lighter in color, it has low strength. Okay, it has less durability than the hardwood. Okay, in short, hardwood is the harder parameter inside the tree, sapwood is the softer parameter inside the tree. Okay, sapwood indicates recent growth inside the tree. Okay, just after hardwood, okay, just after this layer sapwood is present. Okay, with this let's go to question number next. Okay, is a thin sap layer, fill in the blank, is a thin sap layer that exists between sapwood and inner bark. Okay, now let's see where inner bark and sapwood is, then in between that let's find out that specific layer the question is talking about. Okay, see, this is what? Sapwood. This layer is what? Sapwood. And this is what? Bark of the tree. Okay, or let's say this specific layer is inner bark. Now they are talking about this pointed dotted layer. Okay, and this layer is called as cambium layer. Okay, remember the name? Cambbium. Okay, the dotted portion which is shown between the sapwood and bark of the tree, or inner bark, specifically saying inner bark, inner portion of the bark, is called as what? Cambium. Okay, cambium is nothing but a sap that has not got converted into wood, sap which is yet to become wood, which is yet to become wood, is called as what? Cambium layer. Okay, it is kind of softer. Okay, if you do the comparison of hardness of layers which are present inside the wood, then the hardest one is pith, then harder is the hardwood, then kind of softer is the sapwood, then literally soft, literally very very mushy, very very soft layer which is found comparatively inside the wood cross section is cambium layer. Okay, it is cambium layer. Okay, let's go to question number next. Fill in the blank is present as outermost element. Okay, let's see diagrammatically which one is the outermost element. This one's bark. Okay, the layer that I am putting this brown line is bark. Okay, have you noticed the paint color? I am using brown color today because we are talking about timber. Okay, that was the reason behind choice of the brown color. This one is what? Bark. We are talking about bark. Okay, bark is the outer coating present. Now we are talking about what? Okay, question is present as outermost element, then bark is there, and then inner bark is given, therefore we cannot directly tick bark. This specific word has got wrong. Then since inner bark is provided, then inner bark is not the outermost element. Then comes this word cortex. Okay, now remember, cortex is equal to what? Outer bark. Okay, knowingly in option outer bark this word is not specified, instead they have provided the synonym for outer bark which is cortex. Okay, this is what? Cortex. Okay, and the inner layer of the bark is what? Inner bark. Okay, there is no word defined for inner bark, just like outer bark is having a special name which is cortex. Okay, remember, cortex is present as the outermost element. Cortex is which one? This bark's outside section. Okay, let's go to question number next. Pick the correct statement regarding medullary rays. Okay, then the statements are here. They extend along height of the tree. Do they? No, they don't. Medullary rays or medullary lines extend along the radial direction or along cross section. They grow radially along cross section. They do not extend along height. See, when we are talking about height, we are talking about longitude. Okay, this one. When we are talking about height, we are talking about direction, and when we are saying that they grow along radial, means they grow along along the cross section, means this section. Okay, let's say this is cross section a dash. Okay, then along a dash we are saying this cross section, then the medullary rays are something like this. Okay, they look like spider's web kind of thing. Okay, the first statement is wrong. Then they carry sap along tree length. No, this is not the function of medullary rays. Point number 2 is literally wrong. Okay, they have nothing to do with sap of the tree. Okay, sap of the tree means what? We just saw it is blood of the tree that carries nutrients, water content, and other essential mineral for growth and maintenance of the tree. Then point number 3 that they are saying is they hold annual ring of hardwood and sap wood together. Yes, this point is correct. See, for example, this is the wood cross section we are having here. Let's say here, let's draw it over here. This is the wood cross section here. Then these are the annual rings. Okay, and this is the pith, that is centermost section. Then these are the medullary rays. Okay, they grow radially. Okay, they just look like a spider webs woven. Okay, these medullary rays do what? They hold the annual rings together and sap wood together. Okay, they hold the annual rings of hardwood and sapwood, not softwood. Okay, softwood we can say to sapwood. They hold the rings together. Okay, these are what? Medullary rays. Okay, the name itself they are indicating rays. See, let's say if pith is the center, then these are the rays. Okay, remember this. This in any diagram, if you are asked which are medullary rays, you should be directly taking this point. Okay, all right. Then point number 3 is right. Therefore, option that we should find is only 3. Point number 3, point number only 3 is correct in the given statements. Okay, let's go to next question, please. Property or properties of a good quality timber is are. Okay, there may be one or there may be more than one. That's why option all of the above is also provided. Okay, For good quality timber, when we are saying that it is having close annual rings, then it means that the growth of the tree is slow. Therefore, slow growing trees do have more strength, and fast growing trees, that is such as conifers, deciduous, are slow growers. Then they have close annual ring, they are having good strength, and it is the essential property of good quality timber. Therefore, close annual ring is a good choice of good quality timber selection. Then compact medullary rays. Okay, see, compact medullary rays presence ensure better resistance to shrinkage. Okay, better resistance to shrinkage. See, this ohm sign I draw is just for the word resistance. Okay, better resistance to shrinkage. Therefore, compact medullary rays existence is good. Point number 2 is good to go. Then dark color, yes. Whatever the dark hardwoods that are present, then whatever the dark variety of deciduous trees are present, or okay, deciduous trees do have a dark color and conifers do have lighter color. Dark colors is a associated property with strong, better and durable wood. That's why this one is also good to go. Therefore, the option we should go with is all of the above. Okay, all of the above is the required option. Then state whether the following statement is true or false. Okay, then statement is striking timber to produce sound is the test adopted to test its quality. Okay, see, we are talking about striking two logs of timber together. Then what kind of sound, what kind of wavelength we are going to obtain? Okay, see, this kind of test is done in testing of brick. Okay, if you remember this, when two bricks are struck together, what do? They kind of produce a metallic clinging kind of sound. Okay, metallic clinging sound is produced when we are striking two bricks together, and this is indication of good brick. Okay, and same thing can be done with timber also. Okay, if you take two timber logs and if you strike them together, then a kind of good quality, fulfilled, deep, rich sound can be heard. And if you strike a timber of low quality or kind of rotten or kind of dampened kind of wood, you will be hearing some kind of dampened sound. Okay, it will not be sharp, it will not be kind of pleasant, it will not be pleasant. It's kind of pounding your fist on a table like this. Okay, this kind of dampened sound you will be hearing when you strike together a kind of rotten timber, not so good quality timber. If you strike a good quality timber, then a distinguishable, the typical wooden sound you will be hearing. Okay, for example, let's say if you are playing cricket or hockey or whatever game you are playing with wooden kind of material, then if you strike together two bats, okay, two cricket bats or two hockey stick, the sound that you get is the identity of good quality timber. Therefore, we can say that striking timber to produce sound is a test adopted to test its quality is the true statement we have. Okay, let's go to question number next. Then compressive strength of a timber is tested along the grain, across the grain, both, and none of the above. Let's say how compressive strength is tested. Let's say this is a log of wood. Okay, let's say this has been put vertically like this has been cut and processed properly. Then when we are talking along the grain, see, I've just told you that grain's alignment is always along the vertical growth of the tree. For example, if we are talking about these fibers, these grains, then these grains or fibers are always directed toward the height parameter or longitude parameter. Then when we are saying along the grain, we are talking about testing it along parallel axis toward the grain, means testing it like this. Okay, this is along the grain compression test. Then across the grain compression test will be performed like this. For example, the same log of wood, from the same sample, we will take the log of wood and we will test it across the grain, along this direction or across the grain direction. Okay, means we will be having the test with respect to grain orientation, parallel to grain orientation, and perpendicular to grain orientation. Means this is perpendicular, and we do test, we perform all the kind of tests. Let's say tensile test is there, okay, then say bending test is there, then say compressive test is there, okay, compressive strength test is there. We carry out all these tests along as well as across the grain orientation. Okay, that's why point A and point B is correct. We will go with option C, which is both. Okay, let's go to question number next. Alright, the question is saying compressive strength of a timber is more fill in the blank than fill in the blank. Okay, we have to do the comparison where along what direction its compressive strength, that is timber's compressive strength, is more or less. See, we are testing the timber for its compressive or any kind of property, strength property, along as well as across. Along means parallel to the grains orientation, across means perpendicular to the grains orientation. And whenever you are carrying out a compressive test, you will find out that when you carry out the test and put the stress direction along the grains orientation, then you will obtain better or more compressive strength of the timber parameter. Okay, when you are going to test the timber for its compressive strength across the grain section, then their strength is not that much in lateral direction. Okay, in lateral orientation, the grain do not possess that binding, that kind of adhesion or let's not adhesion, cohesion in between the grain. Okay, that's why when you are testing the timber for its compressive strength along the grain direction orientation, you will have more compressive strength than across the grain. Okay, that's option A is correct. Therefore, what you will write here, compressive strength of a timber is more along the grain than across the grain. Okay, parallel to the grain orientation, more compressive strength, then lateral or perpendicular to grain orientation, less compressive strength. With this, let's move to question number next. Okay, for application where timber log is meant to be used as strut or column. Okay, strut or column, which strength parameter stands important? Okay, which strength parameter stands important? See, let's see what the question is saying first. For example, we are using our timber logs as column or strut. In short, the timber log or wooden log is meant to be kept on a surface and they will be used as a vertical member. Okay, we are intending to use the timber log or timber or wood as vertical member such as strut, short column or just a vertical member in any construction purpose. Then we just saw that the strength, okay, whatever the use of these columns will be put to, they will be obviously loaded with something. Okay, they will be loaded with something and all the stress will be coming in the longitudinal direction. Okay, then when we are saying that they are meant to be used as column, means they will be receiving a kind of compressive load. Okay, and we just saw the compressive load is taken by the timber when it is loaded along a direction which is parallel to the grain orientation. Okay, that's why the strength along grain parameter stands important when you are intending to use the timber log or the wood as a strut or column or a vertical member. Okay, strength across grain is not that much, that's why it will not be useful when we are going to use the timber as a vertical member in construction purpose. Okay, all right, let's go to question number next. Okay, generally for a timber the tensile strength is measured. Tensile strength, okay, we just saw compressive, now we are talking about tensile strength. See, along the grain, across the grain, both, none. We just saw that any test that you are going to carry out, it is generally carried out for a member along or across direction or any given direction. Okay, and the major directions are x-axis, y-axis. Okay, means vertically, along, across, horizontally. Okay, when we are going to use a timber as tensile member, okay, then we will have to know the tensile strength of that specific member. So we do carry out the tensile strength test of the timber log in across the grain direction also and along the grain direction also. In both direction, parallel or longitudinal or lateral or perpendicular. All these two direction we are going to carry out the tensile strength test. Okay, let's go to question number next. Okay, all right. Tensile strength of a member is equal to how much compressive strength along the grain. Okay, then it is the standard thing that whenever we are talking about tensile strength of the timber is how much of the compressive strength of the timber along the grain, it is always 2 times. Okay, remember the thumb rule, T is equal to 2C along the grains. Okay, T is equal to twice the compressive strength. Therefore let's go with T is equal to 2C, which is option number C, 2 into compressive strength of timber along the grain. Okay, along the grain means in specific this direction. If you are testing compression and if you are testing tension, then you will find out that whatever the value of tension you calculate or determine, it is always twice the compression strength value. Okay, T is equal to 2C, remember it for timber. Then let's go to question number next. Okay, select the correct statement regarding bending strength of timber. Okay, timber can withstand heavy dynamic bending stress? No, timber cannot withstand heavy dynamic bending stress. It can sustain, it can withstand heavy static, okay, continuous static test. Moving loads or vibratory kind of bending stresses it cannot sustain, but yes, you can put it to use where static bending stresses are encountered to, are likely to be encountered wherever you are putting your timber member. Okay, timber member. Then static bending test over a timber sample is done at 1 point or 2 point. Yes, you can carry out the bending test, specifically static bending test, at 1 point like this, okay, like this, or at 2 points like this. Okay, it is just kept like this. Okay, it is kept, 2 points are used, then 1 point is used for testing. Okay, therefore point number 2 is only right. That's why we will go with option C. All right, let's go to question number next. Sawing a timber is easier. Okay, in which direction you are going to saw the timber? Along the grain or across the grain? See, let's see the timber sample again. For example, this is the timber and this is the grain arrangement. Then obviously, if you want to cut grain in this direction, let's take a saw like this, and if you want to cut the timber into this half, okay, this half section, then it is easier because along the grain shearing strength of the timber member is like 6.5 to 14.5 Newton per mm square, and when you are going to cut the timber section along this section, okay, means across the grain section, then its shearing resistance, okay, its shearing resistance is kind of 3 to 4 times. Okay, means let's say if average shearing resistance along the grain is 6.5 to 14.5, let's say 10, it is 10 Newton per mm square, then across the timber section if you put your saw, you will be encountered with a kind of value which will be 30 to 40 Newton per mm square. That's why sawing a timber means cutting the timber is easier along the grain because shearing resistance is provided less, and when you are going across the grain, then it is encountered 3 to 4 times than that of what you encountered while you were sawing the timber along the grain direction. Okay, enough. Let's go to question number next. Okay, cleavage strength of timber is determined, fill in the blank the grain. Okay, it is parallel, across, or in any direction. Okay, see, cleavage strength is nothing but its splitting strength. Okay, in which direction it can be split easily, it is its splitting strength, and is determined only along the grain direction. Along the grain direction or grain orientation means parallel to the grain. Okay, like this, parallel to the grain, whichever axis you choose in between the timber section, it should be parallel so that you can determine the cleavage strength. Okay, remember, cleavage strength is nothing but splitting strength. Let's go to question number next. Of elasticity of timber along longitudinal axis is generally fill in the blank times to its modulus of elasticity. Okay, or modulus of elasticity along radial or tangential. Okay, sorry, I didn't remember to put this word, along radial or tangential direction. Okay, means we are talking about modulus of elasticity along longitude compared to modulus of elasticity along radial direction or say tangential direction. Then the the thumb rule is that when you are talking about modulus of elasticity or Young's modulus along longitudinal axis, okay, it is generally 10 to 20 times the sorry the value of modulus of elasticity along radial direction. Okay, the thumb rule is 10 to 20 times. And timber's average modulus of elasticity is around 0.5 to 1.5 into 10 to the power 4 Newton per mm square. Okay, it is 0.5 to 1.5 to 10 to the power 4 into 10 to the power 4 Newton per mm square. Okay, and timber is an anisotropic elastic material, means you are going to find out one property or one specific property. Let's say compressive strength is there, let's say tensile strength is there, let's say bending stresses withstanding properties there, or let's say modulus of elasticity there. In one direction, if you go along the timber, you will find the property is different, and in another direction the property will be varying very much. That's why whatever the relation we saw, like in tension, tensile strength, compressive strength, there exists a relation of 1 by 2. Okay, T is equal to twice C we just saw. Then we saw how the compressive strength is there, how the tensile strength is there. Now we are talking about modulus of elasticity, which is varying 10 to 20 times. Okay, 10 times or 20 times more. Okay, that's why we call the timber as an anisotropic elastic material, means its property will vary when you change the direction. Okay, in no various direction you will find the properties are same. That's why we are calling it as anisotropic. Okay, now let's see a diagram that summarizes what the components of the tree or timber we just saw. Okay, in the center, what was there? It was pith. Surrounding the pith, the annual ring, not annular ring, annual rings were what? The annual rings were hardwood. Okay, then we saw the soft kind of wood present in the timber cross section. It is called as what? Sap wood. Okay, then came a layer. Okay, then came a layer which was a sap, but that was yet to become what? That was yet to become sap wood. Okay, that layer was what? That layer was cambium layer. Okay, then we saw a spider's web kind of thing. Okay, it was what? It was medullary rays. Okay, these are what are the things that we are drawing here? These are medullary rays. Okay, medullary rays, let's just name them. Okay, this one's what? Okay, let's change the pen color. All right, okay, black, yellow. Okay, black. Okay, this is what? This is pith. Then this specific section is what? This is heart wood. Then this is what? These layers, these are sap wood layer. Okay, these are kind of soft as compared to hardwood. Then this is what? This line is what? We just drew it. Medullary rays. Okay, then this specific layer, it is a layer of sap which has got accumulated over there but not has been converted into wood. Okay, this is what? Cambium layer. This is the cambium layer we are talking about. Okay, this is what? Inside, inner edge. This inner edge is what? Inner bark. Then the outside is what? Outer bark, or there is a specific name for outer bark. We call it as what? Cortex. Okay, I think that was enough for the initial part. In this part we saw the types of wood: coniferous, deciduous, hardwood, softwood. Okay, then about annual rings we saw, then medullary rings we saw, what is pith, what is cambium, what is inner bark, what is outer bark, that is cortex, then what is medullary ray, then what is sapwood, what is sap, then desired properties such as tension is there, compression is there, bending stresses are there, and modulus of elasticity is there. Okay, in the next part we will be talking about how to preserve or how to prolong the life of timber when we are going to put it to use in engineering project or engineering construction applications. And we will also see the defects, the natural defects or the processing defect that gets accumulated inside the timber, okay, in the next part of the timbers or building materials section. Okay, till then, bye bye, have a good day.